All right, good afternoon, class. So this one is for Algebra 2 Trig Honors, Chapter 7, Rational Function Test, Simple Questions. So we'll look at that some of the problem here real quick. Okay, let me just turn on the lights so you guys can see better. Okay, so now the first one is all about sketching the graph for a rational function. So again, the structure is always consider f of x. So that equals a over the quantity of x minus h plus k. So the value of a, which is considered negative 1, h is 1. And then k equals negative 2. So one thing that we notice, so VA, so which is the value of h. And then HA, the horizontal asymptote, is the value of k. So starting with that, VA and HA first. So VA is 1, so it's 1 unit to the right. So make sure that you need to show me the vertical asymptote, dotted. And then k equals negative 2. Like that. And now for those you might be wondering, A, it's negative, so that means it's reflected over the x-axis. So in order to come up with the positions for the reflected graph, and then we just want to come up with the xy table. So easy number that you want to use. So let's say that x equals 2. So negative 1 over 2 minus 1, then that would be considered negative 1. Negative 1 minus 2, negative 3. So 2 comma negative 3. And then let's find another point in this region here. So let's say x equals 4. So we do have 4 minus 1, which is 3. And negative 1/3. Negative 1/3 minus 2. Negative 2 and 1/3. So negative 2 and 1/3. So at 4, then that would be considered 1, 2, 3, 4. Negative 2 and 1/3. So this point is getting very close to the horizontal asymptote. And now, what about for the other part of the graph here? So let's say that we put in negative 1. Well, let's plug in 0, because you want to find out the x-intercept. So in order to get the x-intercept, so we want to set y equals 0, but this one, is that possible to find the x-intercept? Okay, let's see. And so we try to set it equal to 0. So we do have negative 1 over x minus 1 minus 2. So 2 equals negative 1 over x minus 1. And then cross multiply. So we do have 2 times the quantity of x minus 1 equals negative 1. So 2x minus 2 equals negative 1. So 2x equals 1. So that means x equals 1/2. So for the x-intercept is 1/2 comma 0. Right up here. And now let's see what else. What about for the y-intercept? So for the y-intercept, so that means we want to set x equals 0. So plug in 0 for x, so 0 minus 1, so negative 1, negative over negative, positive. So 1 minus 2, negative 1, so 0 comma negative 1. And then once we get those dots, simply just connect them. As you can see that the tail, the curve right here, so it's getting close to the horizontal asymptote, and the other one is getting close to the vertical asymptote. And on the other side right here, it should be symmetrical. Okay, so connect the dots. Again, this one, the curve, the tail, is getting closer and closer to the horizontal asymptote. Okay, so there's no hole here, so there's nothing you can cancel out top and the bottom, so that means there's no hole. And let's see what else. What about the domain? So the domain for this curve, it's negative infinity all the way to 1, and then union 1 to infinity. Okay? So now let me check one thing real quick. Okay, so now what about for number 2? So number 2 is quite similar, but the thing is that this one is not under the structure of a over x minus h plus k. So for those you might be wondering, when do we use the synthetic division or the long division? So once you see the same power, top and the bottom, then you want to perform the long division or the synthetic division. For this one, once again, the power on the top it's less than the power down the bottom. So that means we want to factor it. So take out 4 in the top, so we do have x plus 2 remain. Denominator, so try to factor it, so we do have x plus 3. And let's see what else. X minus 2. Now for those who might be wondering this one, if that's the same thing, so we can cancel them out, but they're not. So that's why we just keep it this way. So it looks like we do have 2 VA. But anytime they can cancel out the same element top and bottom, so let's say that the denominator is x plus 2, so we can cross them out, so then that we consider there's a hole at x equals negative 2. But this one is minus 2, so there's no hole right here. Okay, so what we want to find out, so the VA, so the way to find out VA, so set the denominator equals 0. So for the VA, we do have negative 3 and positive 2. Okay, so what about for that HA? So anytime they want to find HA, you always want to take out the AND behavior, the highest power term, top and the bottom, and then we just want to take them out and put in for the analysis. So 4x over x squared. So this one will give you that 4 over x. So you might be wondering, as x approaches infinity, so y goes to 4 over infinity, which is getting close to 0. And what about the other side here, the other directions? X goes to negative infinity, y also goes to 0. Because that 4 over negative infinity is getting very close to 0. So we got the VA, we got the HA, so now guess what? Just sketch the graph with the VA and HA. So one is at negative 3, and the other one is right here at 2. And then for the horizontal asymptote, we do have y equals 0, so that means the x-axis. Dotted. And now, in order to get some points, so we need to find the y-intercept. Obviously, there's no x-intercept here. Well, but the things that for the horizontal asymptotes, so one thing you need to watch out. So for the HA, that only applies for the graph on the left bound and the right bound, but it doesn't apply to the graph here in the middle. So you might be wondering, here in the middle, so the line here is still considered solid, straight. Okay? So again, horizontal asymptote, that just shows the boundary of the left bound and the right bound of the curve. As x approaches infinity and x goes to negative infinity. Okay, so now xy table. Let's just plug in 0 first, and then we can find out the y-intercept. So 0 plus 2, then that'd be 2. 2 times 4, then that'd be 8. Over 0 plus 3, then that'd be 3. 0 minus 2, negative 2. So it's 8 over negative 6, which is considered negative 4 over 3, negative 4 third. So it's negative 1.33333. So at 0, so that point right here will be considered negative 1.333. So somewhere over here, the y-intercept. And now you want to put in something that's close to the vertical asymptote here. So let's plug in 1. So 1 plus 2, that's 3. 3 times 4, so 4 times 3. And then 1 plus 3, then that's 4. 1 minus 2, negative 1. And as you can see that here, so it's what, negative 3. So 1, so then that'd be negative 3. Down here on the bottom. And now what else can I put in for the next, for the x value here? So let's put it here. The other one I want to put in negative, let's say negative 1. You know what, let's put in negative 2 and see what happens. Because negative 2, so it looks like that one is going to be the x-intercept. So negative 2 plus 2, that's 0. Doesn't matter what happened over here down the bottom. So 0 divided by everything else, it's always 0. So negative 2 comma 0. Okay, so the middle part of the graph looks like it's going to be like this, kind of like the reflected cubic curve. So it's going down this way. Now what about the left bound and the right bound for the curve right here? So now let's put in something that's less than negative 3. So anything that's less than negative 3, so let's put in negative 4. Okay, so one thing at a time. Negative 4 plus 2, negative 2. So negative 2 times 4, negative 8. So negative 2, negative 4 plus 3, negative 1. And then negative 4 minus 2, negative 6. So it's negative a over 6, which is negative 4 over 3. So negative 1.333. So negative 4, negative 1.333, somewhere down here. And now what about the other side of the curve right here? So let's say something that is greater than 3, or anything that's greater than 2. Okay, so anything that's greater than 2. So let's put in 3. So 3 plus 2, then that's 5. So 4 times 5 on the top. 3 plus 3, then that's 6. And then 3 minus 2, that's 1. Reduce. So 10 over 3. So 10 over 3, which is considered 3 1/3. Okay, so at 3 here, so 3 1/3. 1, 2, 3. I mean, you can get some more point down here as well, but we do know that this one is getting closer and closer to the horizontal asymptote. So for this side of the graph, it's going to be like this. And then the other side of the graph here, decline, like that. And in order to state the domain, so we want to find out the VA again. So the VA, the first one is right at negative 3. The other one is 2. So we do have 3 different intervals for the domain. So one is from negative infinity all the way to negative 3. Union, and then negative 3 to 2, and then union, and then 2 all the way to infinity. Alright? So for the graph. So make sure that you need to set up the timer for doing the practice like this, especially for the graphing. It takes a little bit more time for this. So make sure that you don't want to spend more than 5 minutes for making the XY table, finding the VA, HA. Okay, so now what else? What about for number 3 and 4? So for number 3 and 4, we want to find out the simplest form for the rational expression. So one thing that you want to do, you want to factor this first. So 15n to the power of 3 minus 21n squared. So take out the greatest common factor, because that's just a binomial. So 15 and 21, so things that they share in common, then that would be considered what, 3. And then n to the power of 3, n squared. So n squared, that's what they share in common. So what's left here is just 5n minus 7. Denominator, that's a monomial, so we just want to bring it down. And now what about the other binomial here? 10n squared plus 40n. So take out 10n, greatest common factor. Again, if that is given as a binomial, we just want to look for the greatest common factor. So we do have n plus 4. Okay, making sure that it's correct. So n plus 4. And then denominator, we want to take out 10n. So we do have 5n minus 7. Now before you cross out anything here, you want to find the excluded value. So the excluded value, that means we want to set the denominator equals 0. So, well, 3 obviously cannot be 0, so the only thing can be 0 is just 10n. And then 5n minus 7. So that means n equals 0. And then n equals 7 over 5. So we do have 2 excluded values. And now what about the rest of the structure here? Can we simplify it a little bit? Yes, certainly we can do that. Reduce. So 10n over 10n. Things that we can cross cancel. So 5n minus 7. 5n minus 7. What else can we reduce? The 3. So now things that remain here. So we do have n squared times n plus 4. Okay? Now what about for the division one? Division, so first thing that you want to do, whatever the second rational expression you have, you want to flip it over. because you want to convert it back to the multiplication problem. So for this one, we want to flip it over. So it's 10a minus 20 over 27a minus 36. And then the first one, we just want to bring it down, or you want to factor it. Well, we can do that in the next step here. Okay, so once you convert it back to multiplication, so now you want to factor it top and bottom. So 9a squared minus 21a plus 12. So take out the greatest common factor first. So take out 3. So we get 3a squared minus 7a plus 4. And then 3a minus 3. So take out 3. So we get a minus 1. 10a minus 20. So take out 10. So we get a minus 2. 27a minus 36. So we take out 9. So we get 3a minus 4. Now for those who might be wondering, what about the trinomial? Can we factor that a little bit more? Yes, certainly you can do that. You can either do it on the side with the smiley face method, or you probably want to do it mentally. So 3a squared, just 3a times a. 4, then that would be what? Negative 1 and negative 4. Or negative 4, negative 1. Checking the word, making sure that this one is the right setup here. Inner product, negative 4a. 3a times negative 1, negative 3a. So combine them, negative 7a. So the way to put this together, so it's 3 times, the 3 is just the greatest common factor. So 3a minus 4. Again, whatever the things that you have on the left-hand side of the factor trees, so you want to put them together. And then a minus 1, the right-hand side. Everything else, just carry them over, bring it down. So once you factor the form completely, guess what you can do first? Find the excluded values, if there's any. So set the denominator equals 0, so 3 times a minus 1 equals 0, and then 9 times 3a minus 4 equals 0, so a equals 1. And then get a 1 here. A equals what? 4/3. Again, the greatest common factor doesn't matter, because that once you divide by 3, divided by 9, it's cancelled. Okay, so now, once we find out the excluded value, the last thing you want to do, make sure that you want to cross cancel and reduce. So obviously a minus 1, 3a minus 4, and then what else? The 3. And let's see what else that we can cross cancel. Well, nothing, but anything that we can reduce. Okay, nothing. Make sure that you put an equal sign. It shows the consistency right here. So we do have 10 over 9, or 10 times the quantity of a minus 2, all over 9. And that would be the final form. Okay, so now let's see what else that we have on the back board here. Okay, so get a 1 here. Adding, subtracting, rational expression. Well, this one is all considered subtracting. Okay, let's just do 1 for addition. Yeah, I think I forgot something here. This one's supposed to be simplifying the complex rational expression. So plus 1 over x minus 3 plus 1 over x plus 1. Okay, so now for number 5. So for those you might be wondering, how do we simplify the complex rational expressions? So the way that you can do it, you can either convert them to the same denominator, and then you want to convert it to multiplication after that. Another way you can do it, you can just multiply by the least common denominator, top and the bottom, so you can get all the denominator here. So let me show the easiest approach. So just basically multiply the top and the bottom by the LCD. So compare and contrast, so things that they share in common. So x minus 3, x plus 5. And guess what that is? The LCD, top and the bottom. So now, the way to rewrite it, because you want to distribute the LCD, because you want to multiply it out. So this one is just another way to consider rationalizing. Anytime they multiply the exact same thing, top and the bottom, it's always considered rationalizing. So we write it, so we do have x minus 3 over x plus 5, the first rational expression, multiplied by the least common denominator. Okay, so get a 1. 16 over x minus 3. Once again, multiplied by the exact same least common denominator. And what about for the bottom part right here? Similar. So 1 over x minus 3. 1 over x plus 5. So we want to multiply the least common denominator separately or individually. And don't forget to put the plus right in between, because that's the sign right here, that's a plus. It's addition. And also this one, x minus 3, x plus 5. And for those you might be wondering, what's the purpose of doing this? Well, what happens if I multiply the least common denominator? Guess what? Cross cancel. So that means there's no more denominator remaining. So we got x minus 3 times x minus 3, which is x squared, minus 6x plus 9. And this one is just what? 16x times 16 times 5. So 16x plus, and that would be what? 16 times 5? 80. And now what about the denominator? Denominator is just what? X plus 5 times, well, x plus 5 plus x minus 3. And guess what we can do? Combine the like terms. From the greatest power to the least. So x squared, negative 6x plus 16x, positive 10x. 9 plus 80, 89. And then denominator, so then that would be what? 2x plus 2. And for those you might be wondering, can I take out that 2 there? Well, certainly you can do that. Or you can just leave that with the non-factor form. Okay, so simplifying the rational expressions. Again, the easy way to do it, multiply the least common denominator, top and the bottom, and then cross cancel. So once you cross cancel things out, so you can see that things that we can combine here. Okay, so what about for adding, subtracting rational expressions? Okay, so if you look at that, number 6, number 7. Okay, so now for number 6. Just want to get some space right here real quick. So anytime that you want to combine or subtract the rational expressions, so quite similar to the way that I add fractions or subtract fractions, you want to find the least common denominator. Okay? So this one is reducible, so that means it's considered 3 over 1. And then the rest of this, you want to factor it. So p plus a, nothing's factorable, just leave it. But what about this? So 12, 60, and 72, so it looks like they're all divisible by 12. And also they're all divisible by p. So take out the greatest common factor, 12p. So now what's left here is p squared minus 5p. And then plus 6. Okay, so it looks like we can factor this one more time. So the trinomial, so 3 over 1 minus p plus 8 over 12p times p minus 3 and times the quantity of p minus 2. Well, the reason why that we want to factor it because we want to find out things that are sharing common. Well, this one is quite obvious. It's just the same denominator. So for the top here, we just multiply that 12p cubed minus 60p squared plus 72p. Well, sometimes you have to find out things that they share in common. With this one, you just multiply the exact same denominator, top and the bottom. So for the denominator, we just put it into with the factor form. So that's just for the first rational expression. And now what about for the other one? Subtract the quantity of p plus 8 all over, again, the least common denominator. There's no need to find excluded value for this. We just want to simplify it. We just want to subtract the rational expression. Okay, so now, as you can see that, it's under the same denominator. So what we can do, we can just distribute and then combine the like terms. So 3 times 12p to the power of 3, then that would be 36p cubed. 3 times negative 60p squared, negative 180p squared. 3 times 72. So 3 times 2, that's 6. 3 times 7, 21, so 216p. But don't forget, minus p, so then that'd be 215p. And then what about the constant? Negative times positive, negative minus 8. As you guys can see that, the numerator, combine the like terms after you distribute from the greatest power to the least. And then denominator, just leave that with 12p. And then the quantity, p minus 3, p minus 2. And for those who might be wondering, it's a quadnomial. Is that factorable by grouping? Well, I don't think this one can be factored. So just leave it. If this one is factorable, so sometimes you'll see that things we can reduce top and bottom. But this one, nothing you can factor, so just leave it. And now what about for number 7? Again, find the least common denominator, but before you do that, you want to factor this first. So we do have 4 over 7 times the quantity of a minus 1 plus 7 over 5a plus 4. So things that they share in common, so then that'll be 7, a minus 1, and then 5a plus 4. Okay, so again, whatever that, if they have nothing in common, so that means you want to multiply those factors together, then that'll be the least common denominator. But now, here's the key step here. Make sure that you need to find out the missing element, top and the bottom. So this one, we need to multiply by 5a plus 4. Top and the bottom. And then this one here, we need to multiply by 7, a minus 1. Well, because that's missing. And now the next step, after you convert it, so you want to distribute. So 5a times 4, 28. 4 times 4, 16. 7 times 7a, 49a. 7 times negative 1, well 7 times 7 times negative 1, then that would be negative 49. Okay, so we've got to be careful of that. Multiply those two 7s first. So 49a minus 49. Once again, the same denominator, so we just need one of them, because I would want to put this all together for the next step here. Combine those like terms. So 20a plus 49a, 69a. And then 16 minus 49, so negative 3, and then negative 33. And for those who might be wondering, well, it looks like we can take out 3 on the top. Yeah, you can do that, but nothing can reduce down the bottom. You can either leave it like this, or you can take out the greatest common factor. So that's the final form. Okay, so now, what about the last two problems solving rational equations? So anytime that we solve for the rational equations, sometimes we do have one solution or two solutions. If there's only one solution, guess what? It's optional whether you want to check your work or not. But it means that if that's considered two solutions, so that means you want to verify the solution. Because one of those might be considered the extraneous solution. Extraneous, that means the solution is invalid. Okay, we're going to find out. Okay, for the next one. Okay, so take a look at that first. R squared, R squared. So this one is quite similar to the structure of simplifying the complex fractions. So find the LCD first, which is R squared. So multiply everything by R squared, both sides. Again, the purpose of doing this, cross cancel. After you distribute, this one cross cancel, cross cancel. So now, what's left here is just 6r minus 6. So that equals r plus, well, r squared got canceled, so it's only what? R minus 4. And as you guys can see that, once we multiply by the least common denominator, so there's no more denominator remaining. And then for the rest of this, combine the like terms. And then we simply solve for r. So we're going from rational functions to the linear function. So 6r minus 2r, 4r. And then negative 4 plus 6, which is 2. So r equals 2 over 4, which is what? 1/2. So once again, if that's just one solution, you don't need to check your work, because that it's always guaranteed it's the valid solution. But what about if that's considered two solutions? Then you have to check your work. Okay, so now this one here, before you find the least common denominator, so let's just factor all the denominator first, because you want to find the LCD. So factor, so we do have 2r minus 10 over r plus 1. The first one is non-factorable. I mean the top, there's no need to worry about the top. Denominator, we do have 3 times the quantity, 3 over the quantity of r minus 3, and then r plus 1. Okay, so as you guys can see that, the least common denominator, which is r minus 3, r plus 1. Okay, so multiply the LCD, r minus 3, r plus 1, for all three rational expressions. This one here as well. Okay, so now, as you guys can see that this one got canceled. Whoops. R plus 1 get cancelled. And then this one here, r minus 3 get cancelled. This one here, r plus 1. Okay, so now let me put it back up here. So what's remain here? We do have r minus 3 times 2r minus 10. So it looks like that one's going to be quadratic. You try to multiply it out. Minus, over here, well basically this one everything got cancelled. So except the 3 right there. So minus 3. And then for the one on the right hand side, so we do have r minus 3 remain. And then for the binomial FOIL, first outside, inside last. So 2r squared minus 6r minus 10r, then that'll be minus 16r. And then negative 3 times negative 10 plus 30 minus 3 equals r minus 3. So making sure that this one is correct. Okay, yeah. And now the rest of this, since we do know that's a quadratic, so that's why you want to bring everything all together to one side. So 2r squared, negative 16r minus r, negative 17r. So 30 minus 3, then that'll be 27. And then 27 plus 3, so then that'll be 30 again. Or we can just cross out the negative 3 now. Now, is this factorable? Let's find out. So 2r, r, 30. So 30 we can use negative 15 and negative 2. Okay, so we got negative 2r, negative 30r. Well, that doesn't work, okay? So wait. Because the one in the middle, it's negative 17. So we gotta be careful. Okay, so another way that we can put in for this one, let's try 6 and 5. Yeah, try negative 6 and negative 5. So what we got here, 30. So we can put it in as what? Negative 5, negative 6. So negative 5r, negative 12r. So then that'll be negative 17r. And then put this all together, 2r minus 5, and then r minus 6 equals 0. So r equals 5 over 2, and then r equals 6. Again, don't forget to check your work. Make sure that you need to plug in r back to the original equation, and find out whether that's the extraneous solution or the valid solution. And then for 6, same thing. Plug in a number, back to the original equation. If the value on both sides are equal, so that means it's considered the valid solution. Once you plug in a number, if the value they're not exactly the same on both sides, so that means the solution will be considered extraneous. Okay? So make sure that you need to check the work for the two solutions problem. Okay, so that's it. Make sure that you guys watch the video carefully and try to do some of the simple questions. Alright, so I'll see you guys next time.